Hello everyone, this is Singer. Today I'm going to talk about function in math. So previously I have uploaded the animation of those functions using Manim, and I guess it's available in YouTube right now. So here's a snapshot of all the functions. That is like a parent function, you can expand it however what it is the situation. Those are just some of the parent functions that are representative of the characteristics of those functions. So this is just a brief overview, and you can maybe have a snapshot also for reference, or you can refer to the animation I posted previously on YouTube. So let's move on to the first one. First one, we have y equals a constant. In this case, the constant, of course, is constant. This case is 2. This means, for example, the most convenient way to use Excel to plot out those functions is that the input is simple and the output is also simple. So you don't need a very large data set. For example, if you need a very large data set, you definitely need to use Python, such as a lot of data generator. You use NumPy, and then you want to plot it, you can use the Seaborn Matplotlib. If you want to simply plot it out, the quickest way maybe use a SymPy, because it just passes in the function and the data input and output is generated on itself. However, those methods using Python, you don't have the tangible feeling about the logic behind it, how it works, because so let's just assume that prior even to the days of using Excel, those functions you have, for example, you can imagine a mathematician or whatever it is having is working on a piece of paper using pen or using maybe blackboard, using chalks or some stuff. You might have use one column as input and the other as output, so you guess the coordinates. And first we can look at it. This is exactly the function we're talking about. This is the x, the input. The input doesn't have anything that will influence the output or changes the value. It stays constant. It means it is not changing. So therefore we have a -8, and it's also 2, and you have on the other end of the extreme value you have a +8, and the output is also 2. Therefore you have a line basically. So normally, if I guess in most of the cases it just have a straight line. In most cases you check out those either curves where this is a straight line, this is like a staircase situation, or this is a curve and this is a parabola, also like this. However, whenever there's a line, we need to be able to associate the value, the data, the input and the output and behind this one. So I guess it's best to use a scatter plot. Use this one. Maybe we can change this one. We can let's just maybe change some other stuff here. Use dots instead of the square. So, and this is the initial phase. We should have a scatter plot, because this is exactly associated with the values. Maybe I need to just give you a better sense of what's happening. For example, this red dot, you can see if you draw a vertical line, is residing on this intersecting with this spot on the x-axis. So this is the tick reads -8. So, and this is the y, and you have a horizontal line. This is the y value of 2. Thus is corresponding to this spot. You have a -8 is residing on the axis value, and then you have a y value of 2. Thus this pair of x and y coordinate forms the coordinates that define the position of this dot, the red dot. So it's the same like this one. If you want to be a little bit dynamic or want to keep track of everything, you can just clear the contents of it. So just, for example, we just want to check out the two extreme value on both ends. You just clear out the contents. This is the first step. Now, because we're not doing it on paper or pen, you can do it on paper or pen, of course. This is the first step. For example, we're plotting out, we're labeling everything. For example, maybe we can add some labels, some stuff here. Maybe we can have some value in center above, maybe like this, and then you have some value, I guess in the early days when they need to do this way, so like a pair x, y, and then you move on to plot out the next dot. Next is -7. Maybe I can adjust the interval between, so we have a good sense of it. Therefore, this dot is residing on the x-axis at the spot that reads -7. Then you have all of these dots plotted out, and at this phase, I guess we could use the line to connect. It's like a necklace. You have a pearls and you use a strand, you just to connect them and form like this. If you I guess most of the cases can be simplified just using a line plot, so like this. So basically this is the procedure behind it. Then we move on to the x equals x, y equals x. That means whatever the value that is used as input, then the output are exactly the same. Therefore, you have first quadrant and the third quadrant. The third quadrant features -y and -x. The first quadrant features positive x and positive y. Therefore, it's like one-on-one relationship. You have a -8, and then you have a y, of course, also is -8. In this case, we can also have another scenario. You have a absolute value. Absolute value, you can envision it. It's like a check mark. You have a V shape, because although the value on the x-axis, the input, however, on the y direction is positive. So we definitely have, we can try it out and pass in the variable and then check out the results. It's definitely, maybe I just keep the format so I retype again. Normally just drag it down and then you will have an auto completion. So I just don't want to disturb the format I have set up. It's alright, you can just drag it out and pass in. You have a V, because this is corresponding to -8, and because it's absolute value, you have a positive A. So this is the x. I guess right now we're covering, we still got one more. That is the power is also 1. We move on to power equals 2, power equals 3, power equals 4. And then you can play out on your own. And at this phase we have a floor just truncating the value behind the decimal points. For example, you have a 2 point, and all those is like within the range of a 2, -2 and -3. So the all those decimal places were truncated and leaving only the integer of -2. Sorry, I guess I made a mistake here. Let's just keep consistent. So the upper half is negative. And you have stairs. I guess we can also switch type if we want to have a line. And so like this, you have a staircase, and then if you want to have we can just try it out on your own. Maybe so like this with the dots connecting in between lines. Yes, this one looks better. Oh no, so curvy lines. You can try it out on your own. This is just the dots. It's the same process. You plot it out every dots, and then you have a. So this one looks good. Maybe this one. Because why the shape is like this? It's for example, this value is -2. It hasn't changed yet. The axis keep on increasing or decreasing at this situation, because as we're talking about negative value, definitely is decreasing, and the y stays constant at the interval. At the interval, for example, you're having 0 to 1 to -1 to -2, then you have -1, because whatever the decimal places have been truncated and being omitted and leaving only the -1 integer. The same is about the positive values. So I guess this is it. This 3 plots covers the x, f, the function of y equals x. The power is 1, and also you can just combine this as 1. And then we have the y that is raised to the power of 2. If you raise to the power of 2, of course, even if you're passing in negative value, you have positive value, because it's squared out. And then you have those dots connecting, and this is the first step. Each one, for example, this red dot is corresponding to this pair of x and y. When the x is -8, the y, because it's 8 times 8, double negative negate themselves, so you have a positive. So this is the curve, the parabola curve, and then you move on to other coordinates. You plot it out. There's like a scatter plot. Then you can manipulate. Maybe you can change it using a line to connecting those dots, or you just simply, maybe just for the sake of simplicity, just get rid of the dots and form a simple line. So this is how it is. And also the vertex, of course, is a 0, because there's no shift or shift in the x direction or shift in the y direction. We will cover later, right after the negative x squared. So we move on to the negative x squared, because you have a negative sign in front, and even though the squared value is positive, yet the negative sign negates all the value, all the positive value into negative value. So it definitely won't covering the first and second quadrant like this. Like this is the first quadrant and the second quadrant. Therefore, it resides within the third and fourth quadrant. This is how it is. When you pass in those values and you have a negative sign, it turns all the values into negative. It's the same. It just opens down. This is a big smiley face, and this is a frowning face. It's like a grumpy face, and starts yelling. So this is a negative. Negativity of captivity because it's negative. Is having a frowning face and just grumpy, and so we move on. This is some manipulation about the square, and also you have a name specific associated with this form of the ax raised to the power of 2 and plus b x and c. You have this one. So this one is just this is the x raised to the power of square root 2 is the grandfather. These are just grandchildren. You have some manipulation and you have some different formats just to have a little bit different flavor or characteristics. Yet they trace to the same origin. It's just x raised to the 2. And also you have a name quadratic because maybe from you have a square is like this. You have outside this side, then you calculate the area. You have a square. Then maybe you have 4 sides. This quarter, the etymology and meaning is 4. So like a quadrant, quarter, quarantine, and some stuff like that. And then let's just see this example. For example, we have the x direction. We moved 3 spots, 3 units, and this is why there's a negative was wrapped inside the square. It's shifted, the vertex shifted because you just want to have a 0, then you need to have a 3 here. So then you have the y direction is being lifted up 5 units because it's a little bit, maybe we can manipulate the axis a little bit, maybe like this. It's pretty much won't be that significant because the value is not out of proportion. For example, if we reach like 1,000 words, if there are 5, you won't be even just notice it. However, I guess 135 is still okay. We can see it. So this is it. The internal, we shift it x direction, and if we have any constant that is added or subtracted from this squared value, and then it's definitely manipulating the y direction, even or shift up or shift down. So I guess we covered the square, and then we have another one. This is the similar, because this one can be expanded. You have a positive 1 and negative 1. You have 2 intersecting with the x-axis. You have a negative 1 because you pass in a negative 1. This is a 0. You positive a positive 1. Then this positive 1 minus 1 equals 0. So you have a 2, like a crossing area. And also you have a 0 because it's the same. X with 0 we can. And then you have the x raised to the power of 3. This is it's like the quadrant is 1 and 3. It's similar like this one. Oh no, it's similar like I guess we don't need to use this one. We just they can act it. So like this one. If you have a cubic raised to the power of 3, Then input negative, output negative, input positive, output positive. We can clear out this, just the same. Can also clear out, you can manipulate, and then maybe you want to remove the line, just plot out the scatter plot, because each square is corresponding a pair of coordinates. And then after that you can use a line connecting it maybe, and then remove the marker. So this is the x raised to the power of 3. So then we move on to x raised to the power of 4, because whatever the input, no matter it's negative or positive, the output will always be positive. It's like you have x is the same like this one. You have x raised to the power of 2. It's a smiley face. However, this is like a rice bowl. You have a bowl of ramen or noodle, you can slurp it. So this is it. And anything else I didn't cover? I guess I have covered it. I will upload it into the GitHub so you can download or practice on your own. So thank you.